Hey everyone, and welcome back for another deep dive. Today, we're going deep on something that, well, let's face it, probably keeps you up at night. Debugging. Debugging. But not just any debugging. Today, we're going to be talking about debugging at a massive scale.
Like large-scale systems.
Exactly. You know, these really complex systems that are getting more and more common these days.
Yeah.
Have you ever felt like you're chasing ghosts in a system so big you can't even wrap your head around it?
Oh, all the time.
Well, that's what we're going to be talking about today.
We're going to try to give you some tools to deal with that.
Right.
Yeah.
And some insights into how to approach these problems. And, it's funny how much software development has evolved,
Yeah.
but the way we find and fix bugs often feels, kind of stuck in the past.
Yeah, it really does. Like we're using the same basic tools and techniques.
Even though the systems we're building are so much more complex.
Exponentially more complex.
Exactly. And that's what makes this topic so interesting. We're going to explore how debugging itself has evolved over time.
Yeah.
And then we'll dive into this company called Antithesis that's doing something completely different.
Really interesting company.
Yeah, they're calling it multiverse debugging.
Have you heard about this?
I have, and it sounds pretty wild. But before we get ahead of ourselves, maybe we should rewind a little bit.
Yeah.
Take a quick trip down memory lane.
Back to the good old days. Well, maybe not good old days.
Yeah.
When debugging was, well, a whole different beast.
I mean, can you imagine trying to debug with a typewriter?
Seriously, that's actually how they did it back in the 60s.
A typewriter?
Really? Yeah. There was this tool called the DEC debugging tape, or DDT. It was like state-of-the-art back then. It let you modify a program while it was running, but it was a painstaking process.
I can't even fathom that. I mean, no breakpoints, no easy way to inspect variables.
It was rough.
Major headache.
Yeah, and it wasn't just DDT. There was this other tool, the online debugging tool,
Okay.
ODT, and that one you had to use, get this, octal addresses
Wow.
to access memory.
I can't even remember what octal is.
Yeah, exactly. So you can imagine it was all incredibly manual and error-prone.
So how did we even get from debugging with typewriters to what we have today?
Well, it was a gradual process for sure. A lot of brilliant minds working on this problem.
Yeah.
One of the biggest breakthroughs came with the development of symbolic debuggers.
Okay.
This was back in the 70s. Thanks to languages like, C, Fortran, and COBOL,
Yeah.
they started using symbol maps. Basically a way to map human-readable variable names to their memory addresses.
So you didn't have to, remember these crazy hex values.
Exactly. You could actually see the names of the variables.
That's a lifesaver.
It made debugging so much more intuitive and efficient.
Absolutely.
And then towards the end of the 70s, another game changer, breakpoints.
Oh, yeah.
Right.
Breakpoints, finally.
You could halt program execution at a specific point
Right.
and inspect the program's state.
The debugger's best friend.
I know, right? But even with these advancements, things were still pretty limited.
They were, yeah.
The real shift toward what we consider modern debugging
Okay.
came in the mid-'80s. Integrated development environments, or IDEs,
Yeah. IDEs.
Tools like Turbo Pascal, they provided this visual interface for debugging.
It made things so much easier.
Yeah, stepping through code, setting breakpoints, inspecting variables.
It's amazing how much IDEs have changed how we write and debug software.
Totally, they're just indispensable now.
They are. And it just kept evolving,
Yeah.
leading to things like remote debugging over networks.
Oh, yeah.
Debugging code running on a different machine.
Super useful.
So fast forward to today. We've got tools like time travel debugging,
Right.
record and replay debugging, even AI-assisted debugging.
Yeah, it's pretty amazing what's possible now.
But the thing is, as systems have become even more distributed and complex,
Yeah,
these traditional methods are starting to show their cracks.
they are. They're not enough anymore.
Right, because now it's not just about a single program running on a single machine. We're dealing with multiple processes across a network of machines.
Often with asynchronous communication and complex interactions.
Exactly. It's a whole different ballgame.
Yeah, it is. And that's where Antithesis comes in.
Okay, so what's so special about Antithesis?
Well, they're taking this radical new approach to debugging.
We've got time travel debugging. What else is there?
Yeah, so Antithesis is all about this thing called deterministic simulation testing.
DST.
Yeah, imagine this. You're trying to reproduce a bug in your production environment, right?
Right.
but it's intermittent.
Like it only happens under very specific conditions.
Exactly, those hard-to-replicate situations. DST lets you recreate those exact conditions in a controlled environment.
Okay, so it's not just rewinding and replaying your code, it's recreating the whole environment.
Exactly. It's like turning your production system into a time machine.
That sounds intense.
It is, but it's incredibly powerful.
Okay, so with this time machine thing, does it mean you could do things like add logging retroactively, like see what was happening at a certain point in time?
Absolutely. You can rewind to any point in time, attach a debugger,
Wow,
step through the execution as if you were there when the bug happened.
that's wild.
Yeah, you can even modify code in the past to see how it would impacted things.
This is starting to sound like science fiction.
I know, right? But they actually pull it off. Their secret sauce is this thing called a deterministic computer, or hypervisor.
Okay.
It's the foundation of their whole platform. They control every aspect of the environment with this hypervisor.
So it's not just about making your code deterministic. They're making the whole platform deterministic.
That's the key. It lets them do some pretty crazy stuff. They combine techniques like fuzzing, assertions, and shotgun debugging.
All in this controlled environment.
Right. So fuzzing, that's bombarding your system with random inputs to trigger weird behavior.
Right.
Assertions are like checks in your code to make sure certain conditions are met. And shotgun debugging, that's where you run multiple tests at the same time, varying different things to see what breaks.
And they put all of this together.
Yeah, it's mind-blowing, but it works. They've helped companies track down bugs that would have been impossible to find otherwise.
So real-world applications. We actually have some excerpts from an interview with Will Wilson,
Oh, cool.
one of the co-founders of Antithesis. He talks about the challenges of debugging these massive systems.
Yeah, like what kind of problems are they seeing?
Well, Will starts by saying something that probably resonates with everyone listening.
Okay.
He says, in large systems, bizarre failures are a certainty.
He's not wrong.
Not if, but when things go wrong.
And often in unpredictable ways.
Right, like ways you couldn't have even anticipated.
And expectations are so high now.
They are.
Users expect these systems to be bulletproof, just keep running.
Even when things fail.
Which is a tall order.
It is. You've got concurrency issues across multiple machines, unreliable networks, lack of visibility.
It's just a whole different world compared to debugging a simple program on your laptop.
Yeah. Will actually uses a great analogy to describe this. He says debugging a large distributed system is an order of magnitude harder than dealing with multi-threaded systems on a single machine.
That's a good way to put it. The complexity just explodes.
And it's not just the technical stuff.
Right.
Will says often no single person fully understands how all the pieces fit together.
Yeah, you're dealing with a system that's also like a complex social structure.
Right. The knowledge is distributed, which makes debugging even harder.
Like a puzzle where you don't have all the pieces.
Exactly. And then there's the time issue.
Oh yeah, time in a distributed system is a mess.
It is. Timestamps are meaningless.
Because you can't guarantee clock synchronization across all your machines.
Right, so you might see an error log, but it might not reflect the actual order of events.
It's like debugging a mystery with scrambled clues, some of them missing.
So how does Antithesis even begin to address this?
Well, Will explains that their platform's being used in a ton of different ways.
Yeah.
Some teams are running short tests on every code change. Others are running longer, more comprehensive tests overnight or on weekends.
So they're not trying to replace everything, just complementing existing workflows.
Right. And some teams just use Antithesis for those super tricky bugs.
The ones that would normally take forever to find.
Yeah, that makes sense. Having a deterministic simulation can be a game changer in those situations.
Will really stresses that they're not trying to disrupt anything or cause any outages.
Yeah, they want to make things easier for developers.
Help them find and fix bugs, regardless of their current testing practices.
That's smart. Introducing a new tool can be scary.
It can be. And you know what's cool about this?
Yeah.
The platform's really versatile. Will says some customers are even using it for more than just traditional debugging.
Like what?
They're using it to understand how their systems behave under different conditions.
Oh, that's interesting.
Yeah, like a virtual lab where you can experiment without real-world consequences.
So you could simulate network conditions,
Yeah.
inject faults,
Rewind and replay specific events.
see how it all plays out.
Exactly. It's a powerful tool for learning and discovery.
And it's probably a huge time saver.
Oh, absolutely. Will talks about how it replaces those tedious tasks that developers hate, like adding logging after the fact, building complex fault injection systems,
Yeah, the stuff nobody wants to do.
or running tests over and over and over again to reproduce a bug.
Those tasks can take forever.
They can. So it's all about making developers' lives easier, you know?
Yeah, give them the tools to build more reliable systems.
Exactly. So they're not just building a debugging tool, they're building a platform for understanding and managing complex systems.
That's a great way to put it.
Now that we have a good handle on what Antithesis does and the challenges it addresses,
Yeah.
I'm dying to know more about the technology behind it all.
Yeah, how do they actually pull this off?
Let's get into the tech stack.
I'm ready. It's pretty impressive, actually. They've got a mix of familiar technologies and some really custom solutions.
Okay, so what are they working with?
Well, their main languages are C, C++, Rust, TypeScript, and Nix.
So low-level languages for performance, Rust for safety and concurrency, TypeScript for the web stuff, and Nix for, I guess, managing it all.
Yeah, exactly. It shows the range of problems they're tackling.
It does. So they're not afraid to go deep when they need to.
No, they're not. They rely heavily on NixOS for their infrastructure.
Makes sense, given their focus on determinism.
Yeah, they need those reproducible environments.
Absolutely. What about data? How do they handle all that data from the simulations?
They use Google BigQuery for data warehousing.
Okay, so a scalable solution.
Yeah, it lets them store and analyze huge amounts of data.
But I bet they needed some specialized tools on top of that, right?
Oh, yeah, they've built a lot of their own stuff.
Like what?
Well, they have this reactive browser-based JavaScript notebook for their multiverse debugging interface, a custom fuzzer, a fault injector, binary instrumentation tools, a customizable Linux environment for customer software, and their own build system.
Wow, so they really have that not invented here mentality.
They do, but it's not out of arrogance. They just found that existing tools often don't cut it for deterministic testing.
They're pushing the boundaries, that's for sure.
They are, and you know what's really interesting?
What?
They actually built their own database.
From scratch?
Yeah.
Why would they do that? I mean, building a database is like a massive undertaking.
It was, but they had their reasons.
Okay, I'm all ears.
They started with BigQuery,
Yeah.
loved the pricing and scalability.
BigQuery's great for huge data sets.
It is, but as they grew and pushed the limits, they ran into some roadblocks.
With BigQuery.
Yeah, it wasn't really designed for the kind of data they were generating.
So what was the problem?
The way BigQuery handles data relationships, it's all about relational data, tables with rows and columns.
Right.
But Antithesis's data is more tree-like.
Okay, I see. Like a branching timeline.
Exactly. Every decision point creates a new branch of possibilities.
And that doesn't fit well with the relational model.
It doesn't. They tried workarounds, even built a custom data structure inside BigQuery.
To try and make it work.
Yeah, but they hit a wall.
So what happened?
They were crashing BigQuery's planner.
Wow, they were literally breaking BigQuery.
They realized they needed a database that was designed for their kind of data.
So they built their own. But how? That's a huge project.
It was, but they had a secret weapon.
What's that?
Antithesis itself.
Oh, wow.
They used their own platform to test and validate the new database as they built it.
That's amazing.
It's like a recursive loop of innovation.
It is. And it worked.
It did. Their custom database is almost finished, and it's already solving a lot of their problems.
They even found it's faster than BigQuery in some areas.
It is. For complex queries and managing relationships.
That's incredible. It really shows the power of their approach.
It does. But it also shows the challenges. You need a deep understanding of distributed systems and the tech behind them.
Right. It's not just about the tools, it's about the expertise.
Exactly. And that's reflected in their engineering culture,
Okay, so let's shift gears a bit. What's it like to work at Antithesis?
From what I've gathered, it's pretty unique.
Well, their location is a bit unusual for a tech company. They're in Virginia, right outside D.C.
Not exactly Silicon Valley.
Not at all. But Will says it gives them an edge.
How so?
There's a lot of engineering talent in that area, but less competition from other startups.
Oh, I see. They can attract and retain top talent more easily.
That's the idea.
And are they looking for, experienced engineers, or are they open to junior folks as well?
They're in it for the long haul. They're willing to invest in junior talent, people from different backgrounds.
Okay.
They have a really low turnover rate, which is pretty impressive.
It is. People must really like working there.
They do. A lot of them have worked together for years, even decades, at previous companies.
Wow, that's a lot of shared history.
It is. And they really try to prevent engineers from getting siloed into specialized roles.
Okay.
They encourage rotation across different parts of their tech stack,
So everyone gets exposure to everything.
pretty much. From low-level hypervisor code to front-end development, machine learning, security, cloud infrastructure.
That's amazing. They're creating well-rounded engineers.
That's the goal. They believe it makes communication and collaboration much smoother.
I bet it does. And it keeps things interesting.
Definitely. And you know what else?
What?
They're big believers in in-person collaboration.
Oh, wow. 5 days a week in the office.
That's right.
That's pretty rare these days.
It is. But they feel strongly that it's necessary for what they're building.
The complexity of it all.
Exactly. They value those spontaneous interactions, the brainstorming, the quick feedback.
I can see that. Sometimes there's no substitute for being in the same room.
There isn't. But I'm curious, with that policy, how do they handle work-life balance?
That's a good question.
They don't even give their engineers laptops.
All right.
Everyone works on desktops.
So you literally can't take your work home?
Nope.
That's pretty radical.
It is, but it helps them maintain a separation between work and personal life.
I guess it forces you to switch off.
That's the idea. They believe it's essential for preventing burnout.
It's an interesting approach.
It is. And they've really cultivated a specific culture, you know?
Okay, what's it like?
They have zero tolerance for disruptive personalities.
Okay.
And they emphasize mentoring, helping each other out.
That sounds positive.
They also celebrate those who go above and beyond.
I like that. A culture of appreciation.
And you know, it's funny, they practice what they preach.
How so?
Remember how we talked about them using Antithesis to test Antithesis?
Yeah, eating their own dog food.
Exactly. They actually gave a talk about it.
Oh, wow. What did they learn?
One big takeaway was the importance of continuous testing and validation.
Makes sense. They're catching bugs early.
Yeah. They're using the platform every day, so they find and fix things quickly.
That's gotta be a huge productivity boost.
It is. But they did run into a classic problem early on,
What was that?
the chicken and egg problem.
Oh, right. How do you test Antithesis before it's powerful enough to test itself?
Exactly. They needed a way to bootstrap the process.
So what did they do?
They built a bunch of custom fuzzers
Okay.
to test different parts of Antithesis while it was still under development.
So a more traditional approach at first?
Yeah. Fuzzing is great for finding unexpected behavior, you know.
It is. And now they're replacing those fuzzers with their own product.
It's like a vote of confidence,
It is. They're all in on deterministic testing.
but it's an ongoing challenge, right?
Oh, yeah. Testing a system like this is never really finished.
They said bugs can be really persistent.
Yeah, I bet.
They even evolved to evade testing.
It's like an arms race.
It is. So they're really rigorous about bug tracking and analysis
They want to understand why bugs slip through the cracks.
and how to improve their testing to prevent it.
That's a great mindset to have.
And it's not just about adding more tests. They're constantly evolving their testing systems.
To catch whole classes of bugs.
Yeah, building systems that are resilient by design.
And they have some interesting ideas about bug prioritization, too.
Oh yeah, they actually discourage prioritizing by severity.
Really? Why is that?
They found that trying to predict how severe a bug will be is often misleading.
Okay.
What might seem like a minor bug can actually trigger a major outage.
The butterfly effect?
Exactly. They said major outages often start with tiny, seemingly harmless bugs.
So what do they recommend instead?
Fixing all new bugs as quickly as possible.
Regardless of how serious they seem?
Exactly. It's about preventing those small issues from escalating.
And Will specifically says to prioritize new bugs over old ones.
Even with a massive backlog.
Yeah. He says it's the most efficient use of time.
It's about preventing those new bugs from joining the backlog.
And Antithesis actually helps with this, right?
It does. It makes it easy to identify and ignore known bugs,
So you can focus on finding new ones.
like a triage system for your code.
Addressing the most urgent cases first.
Exactly. So it's clear that Antithesis offers some amazing benefits,
It does.
but it's not a magic solution, right?
No tool is.
There are trade-offs to consider.
Absolutely.
So what are some of the potential downsides? What should developers be aware of?
Well, one thing is the learning curve.
It's a complex tool.
It is. You need to understand how to instrument your code, define assertions, interpret the results.
It's not just plug and play.
No, it takes effort and experimentation.
And what about external services?
That can be tricky,
You might need to mock those services.
which can add complexity and maybe even inaccuracies.
And Phil Eaton, a staff engineer at Enterprise DB, brought up another point.
Oh, what's that?
He said tools like Antithesis might not be as valuable in environments with constant code changes,
Okay.
especially during early prototyping.
When things are still fluid.
Exactly. The overhead might not be worth it.
He also emphasized the importance of ROI,
Right. Antithesis can be expensive.
Okay.
You need to weigh the costs against the potential savings.
It's a business decision as much as a technical one.
And at the end of the day, it's just a tool,
Yeah.
right? It won't solve all your problems on its own.
You need the right mindset and engineering culture.
A willingness to adapt and embrace deterministic testing.
But even with the trade-offs, it's a fascinating example of innovation.
It is. They're tackling a really hard problem in a unique way.
And they're pushing the boundaries of what's possible.
Exactly. And it makes you wonder, what if this kind of deterministic debugging became the norm?
Not just for big companies, but for everyone.
What if every developer had access to these tools?
That's an interesting thought. What kind of impact would that have?
Yeah, it's pretty mind-blowing to think about, What if everyone could just rewind and replay their code? Like, see every possible outcome.
Explore all the different paths the execution could take.
And find the root cause of any bug, no matter how complex.
It would be like having X-ray vision for your code.
Exactly. You could see the state of every variable, the data flow, the interactions between different parts of the system.
It could completely transform software quality and reliability.
Right. Imagine bugs that used to take weeks or months to fix.
Gone in minutes.
And that would have a ripple effect across every industry that uses software.
Absolutely. Think about safety-critical systems, like self-driving cars or medical devices.
That's where it gets really interesting. Imagine the level of confidence we could have.
Knowing that we can thoroughly test and validate these systems.
Simulate every possible scenario, every potential failure.
And make sure the software can handle it gracefully.
It's almost like this deterministic debugging could unleash a wave of innovation.
Because developers would be less afraid to experiment, less afraid to take risks.
Right. Right now, there's so much hesitation to try new things, to adopt new technologies.
Because of the fear of introducing bugs, the fear of the unknown.
But if you could instantly rewind and understand what went wrong,
Yeah.
that fear would start to disappear.
You'd be more willing to push the boundaries, knowing you have a safety net.
Like a safety harness for software development?
I like that. You can climb higher, knowing you have a way to catch yourself if you fall.
But of course, there are always two sides to every coin.
Right. What are some of the potential downsides?
Well, one concern is that developers might become too reliant on these tools
Okay.
and neglect other important practices like code reviews and good design. We can't let tools replace good engineering, right?
Absolutely. It's all about finding the right balance. Using tools to enhance existing processes, not replace them.
And there's also the issue of access. Will this technology be limited to just large organizations?
Or will it become more widely available?
I mean, imagine if every developer, every student learning to code had access to this kind of power.
It could democratize software development, lead to a huge leap in quality across the board.
Right? Even small teams, individual developers, could build really robust systems.
It's an exciting prospect. But there are also some ethical questions to consider, right?
Yeah, when we can perfectly recreate and analyze any software interaction.
It raises questions about privacy, security, accountability.
Right. How do we make sure this kind of power is used responsibly?
That's something we'll need to address as this technology evolves.
But overall, I think it's a really positive development,
It is.
It could fundamentally change the way we build and interact with software.
Make it more reliable, more robust, more accessible.
And that brings us to the end of our deep dive into the world of debugging.
From typewriters to the multiverse.
We've come a long way. I hope you've enjoyed this journey and that it's given you some new insights.
And some food for thought.
Absolutely. Because debugging, as much as we might not like to admit it, is a crucial part of building the software that shapes our world.
It is.
So until next time, keep exploring, keep questioning, and keep pushing the boundaries.
And keep debugging.
Thanks for joining us.